We will have the questions just after the first block of the E3SoHo presentations. So after this presentation, thank you, Andrea, we will have the presentation from Mateusz Zgutka from Mostostal. Mostostal is a Polish construction company which has been in charge of coordinating the pilot site of E3SoHo in Warsaw. So they will explain what experience have been for installing the ICT solution there and what have been the conclusions and lessons learned. Mateusz?
Good morning, my name is Mateusz Zgutka. I'm working in Mostostal, Warsaw, which was one of the partners of the consortium E3SoHo project. I would like to tell about the E3SoHo experience regarding Warsaw pilot site, about installation, conclusions, and lessons learned. Mostostal mainly was responsible for installation and contact trainings with tenants. The first slide shows a short list of issues about which I will speak, and that are introduction towards the pilot site, methodology for implementing specific ICT solution deployed in the pilot site, installation in public, private, and of control cabinet, VAS systems, final conclusions and lessons learned in Warsaw pilot site. Introduction to Warsaw pilot site. The location of the demonstration of E3SoHo was Poland in Warsaw, Szantera Street. The owner of the building is City of Warsaw. The buildings were built in 2007. The demonstration building is a 4-story building. Number of dwellings is 48 in total, but 16 dwellings have been used in the project. In the building lived a total of 111 people, but in the project were involved 32 active users. Existing installation of the building consists of heating. For this purpose was used central gas boiler, DHW, and for this purpose was used also central gas boiler, and the team of the Warsaw pilot site which were involved in the project are City of Warsaw, which was responsible for interaction with tenants, ICP, which was responsible for design of the ICT solution, Mostostal for implementation, Novatek CSTB for evaluation of savings and social acceptance. The next slide shows the scheme of methodology and what we should done to implement. The first step is technical audit of the building with building manager and technician. Second step is define a measured value, for example, temperature presence in the dwellings, which medium we want to measure, and define the zones. The next step is technical feasibility study. Then other is installation in common areas, installation of central unit, installation in the dwellings, where we install sensor and meters, PLC data acquisition and PLC, communication infrastructure, local storage. The next step we should take was test and validation of the system, which if there is everything okay and not needed any reconfiguration, we can go to the next step, configuration of backups and alarms. But if there are some problems, or we need to do the reconfiguration and do that again. The last step is data transfer to iEnergy platform. On this slide, you can see the short list of equipment which deployed in the pilot site. We deployed sensors and meters. For example, electricity meter which measure total and partial circuits. Cabled meters connected via M-bus to measure consumption of hot water and heating. We installed also wireless sensor in dwelling. Wireless sensor because we didn't want to drill the walls and so on. So we didn't want to destroy the design interior of dwellings because the installation equipment was only for demonstration. So to mounting the equipment, we used double-sided type. For communication, we use communication infrastructure composed of ADSL router, LAN, and VLAN. As I said, we install local database for data collection and storage in the pilot, and remote storage and processing. For migration system, uploads data from the pilot to iEnergy platform. Furthermore, we install and graphical user interface for tenants. This is a specific dashboard developed for Warsaw tenants. This is a visual alerted system, and building manager, and for building managers. Installation in public areas, as you can see, is the installation of internet connection in the building, drilling in shafts, cable laying, checking the radio communication. This is the expensive part of the installation. And the probability of investments and cost of that equipment depends on the size of the installation of the building. The next slide shows meters. We should replace hot water and heat meters with meters supporting PLC network. The next slide shows wireless receiver installation and configuration. As I said before, we install wireless sensor, for example, contractors for Windows, sensor for presence, installation, and so on and so on. To inform tenants by application about the weather, temperature, wind, insulation, we installed the weather station on the roof on the building. The data of the weather was collected and sent to the tenants by the application. On this slide, you can see the wireless sensor. On the left is a insulation sensor. On the right side, on the top, is a presence sensor, and below you can see the contactors for the windows. On this slide, you can see electric energy meters, one for light and one for electric devices. The next slide shows the control cabinet which is installed in common areas. We can see modem and router, connectors, input-output modules, Wi-Fi receivers, drivers, and power suppliers. Visualization and alert system. We develop a user interface to collect requirements and feedback from tenants. Main interface for tenants in Warsaw pilot site was available also for other the E3SoHo pilots. Example of E3SoHo ICT solution was interoperability of integrating new user interface through open web services. Our application is compatible with mainstream web browsers and optimized for tablets. The main functionalities was measuring media consumption, inform about physical and comfort parameters like wind, light, temperature, installation. We also have capability to alert tenants for bad behavior. For example, when he go out from the room and not to turn off the light, they get the message that is a bad behavior. The other of the functionality is summary of consumption and comfort data. This is one of the screens from the visualization alert system for tablet. It's average media consumption. The first number presents the average consumption, for example, for energy general, for 1 year. The second number shows the media consumption in each month. By the first number is marked the button which we can see below the media consumption by which we can change between the value of the media consumption and money which we should pay for that media. Our intention was that the users use the tablet with the application only for viewing media consumption, not for playing games or surfing on the internet. For this purpose, we use the application and we used the application programs, for example, Sherlock and browser Surfox, which were blocked the all function of the tablet except our application visualization and alert system. Final conclusion and lessons learned in Warsaw pilot site was this is the big potential for achieving energy savings through ICT awareness tools, but the level of saving may not always ensure acceptable payback periods. Because in some periods the savings were higher, but in some are lower. So this is the problem. But in the overall summary, the savings are in positive and promising acceptable level. Initial energy consumption levels and energy costs are key factors for determining feasibility of investment. Profitability of investments largely depends on the size of the installation. The greater the overall cost of installation and the installation devices are smaller, they spread on the whole system. The most expensive of the equipment is for common area. It's difficult to decouple savings linked to the use of ICT tools from natural savings evaluation. Training sessions with tenants are key for maintaining their engagement. We should, for implementation in that system, we should know that it not consists only for installation the equipment, but also for training session with tenants, which are very important to explain them how use the tablet, the application, and what about the project, about bad behavior, because they don't know about their costs and how that cost can be high. High consumers shall be specially targeted for leveraging global savings impact and at pilot level. At the same time, further work on ICT interfaces is needed to make technology more accessible. Furthermore, tenants need to be more convinced about how ICT can help them to save energy. Thank you for your attention.